In the early 1920s, it was believed that the universe was static, without any movement of expansion or contraction. However, Edwin Hubble transformed this view when he discovered something surprising: galaxies in space were moving away from us, and this speed of removal was related to their distance. The further away a galaxy was, the faster it receded. To explain this phenomenon, a mathematical relationship was created: v is directly proportional to d, where v is the recession velocity of the galaxy and d is its distance. This led to the emergence of the famous Hubble constant, one of the most important numbers in astronomy. This constant value was crucial to understanding the expansion of the universe. At some point in the past, all galaxies were very close to each other before they started to move apart. Going back in time, we arrive at what is known as the Big Bang, the moment when all matter and radiation were concentrated in a single point in space. From this came the concept of Hubble time, which gives us a timescale corresponding to the expansion of the universe, in other words, the age of the universe. By calculating the Hubble constant, we arrive at an estimate of approximately 13.8 billion years for the age of the universe. In addition, Hubble also gifted us with the discovery of redshift, the stretching of light from distant celestial objects as it travels through the universe. The more distant the galaxy, the more its light shifts towards the red end of the light spectrum. These discoveries were fundamental to establish the lambda-cold dark matter (LCDM) model, widely accepted in the scientific community. But it is important to mention another outstanding astronomer, Fritz Wiki, a Swiss, who was one of the most brilliant minds of his time. He drew attention to the existence of neutron stars and dark matter, and was a pioneer in the study of cosmic rays and supernovae. Fritz Wiki disagreed with Hubble's interpretation of red light and proposed an alternative theory, called the tired light model. According to this theory, light photons lose energy as they collide with other particles on their journey to us, which pushes them toward the red end of the spectrum. Wiki theory did not depend on the Big Bang concept. However, on April 1, 1948, a paper entitled Alpha Beta Gamma was published, which provided strong evidence in support of the Big Bang theory. This article clearly demonstrated that elements such as helium, hydrogen, and other heavy elements were formed in the early stages of the universe, which would only be possible due to the Big Bang. With the accumulation of evidence, Wiki's weary light model has been set aside and forgotten. However, the arrival of the James Webb Space Telescope, JWST, is challenging established assumptions and raising the possibility that we may have to rewrite everything we know about the early universe. JWST revealed 6 galaxies that exist 500 million years after the Big Bang and are up to 10 times larger than the Milky Way, which is considered surprising and contrary to expectations. This discovery intrigued the scientific community, which also found clusters of stars called globular clusters, which are extremely old, but show significant differences in the composition of their stars. These abundance anomalies have challenged astronomers, raising questions about the current theory of the creation of the universe. Some theories suggest that these galaxies and star clusters could be monster black holes formed shortly after the Big Bang, which doesn't fit the pattern of normal galaxy formation. In the midst of this scenario, the model of tired light proposed by Fritz Wiki returned through the theoretical physicist Rajendra Gupta. Gupta combined the tired light model with a new model called the covariant coupling constant, CCC. This model considers the 3 fundamental constants: the speed of light, Planck's constant, and the gravitational constant, can vary over time, extending the timeline of the universe. This new approach, known as the CCC plus TL model, provides a different view of the traditional lambda-cold dark matter (LCDM) theory. According to the CCC plus TL model, at redshift 10, the universe is 5.8 billion years old, and at redshift 20, the universe is 3.5 billion years old, providing plenty of time for the formation of stars and galaxies, according to the JWST observations. If this model is correct, the total age of the universe would be 26.7 billion years, which differs significantly from the previous calculation. However, there are still gaps in this new cosmological theory, especially related to the fact that the proposed constants do not seem to affect experiments performed on Earth. We're getting closer to finding the solution to these riddles, but we don't have it yet. The JWST findings may give us answers soon. It will be interesting to see which model prevails based on current and future telescope observations, especially considering the difference in redshift. Which model do you think is most likely? Share your comments with us and stay tuned for updates from CZ Science as we continue to explore this fascinating subject.